Overview: Muslim scientists and inventors, including Arabs, Persians, and Turks, were probably hundreds of years ahead of their counterparts in the European Middle Ages. They drew influence from Aristotelian philosophy and Neoplatonists, as well as Euclid, Archimedes, Ptolemy, and others. The Muslims made innumerable discoveries and wrote countless books about medicine, surgery, physics, chemistry, philosophy, astrology, geometry, and various other fields. Abu Nasr al-Farabi 872–950 Abu Nasr Muhammad al-Farabi was one of the earliest Islamic intellectuals who was instrumental in transmitting the doctrines of Plato and Aristotle to the Muslim world. He had a considerable influence on the later Islamic philosophers such as Avicenna. He was an outstanding linguist who translated the Greek works of Aristotle and Plato and made considerable additions to them of his own. He earned the nickname Malami Sani, which is translated as second master or second teacher. Early life: al-Farabi completed his earlier education at Farab and Bukhara. Later on he went to Baghdad for higher studies, where he studied and worked for a long time. During this period he acquired mastery of several languages, as well as various branches of knowledge and technology. Farabi contributed considerably to science, philosophy, logic, sociology, medicine, mathematics, and music. His major contributions were in philosophy, logic, and sociology, and for which he stands out as an encyclopedist. Contributions and achievements: as a philosopher, Farabi was the first to separate philosophy from theology. It is difficult to find a philosopher both in Muslim and Christian world from Middle Ages onwards who has not been influenced by his views. He believed in a supreme being who had created the world through the exercise of balanced intelligence. He also asserted the same rational faculty to be the sole part of the human being that is immortal, and thus he set as the paramount human goal the development of that rational faculty. He gave considerably more attention to political theory compared to any Islamic philosopher. Later in his work, Farabi laid down in Platonic fashion the qualities necessary for the ruler. He stated that a ruler should be inclined to rule by a good quality of a native character and exhibit the right attitude for such rule. At the heart of al-Farabi's political philosophy is the concept of happiness, in which people cooperate to gain contentment. He followed the Greek example, and the highest rank of happiness was allocated to his ideal sovereign, whose soul was united as it were with the active intellect. Farabi served as a tremendous source of aspiration for intellectuals of the Middle Ages, and made enormous contributions to the knowledge of his day, paving the way for the later philosopher and thinkers of the Muslim world. Farabian epistemology has both a Neoplatonic and an Aristotelian dimension. The best source for Farabi's classification of knowledge is his Kitab al-Ulum. This work neatly illustrates Farabi's beliefs, both esoteric and exoteric. Through all of them runs a primary Aristotelian stress on the importance of knowledge. Thus al-Farabi's epistemology, from what has been described, may be said to be encyclopedic in range and complex in articulation, using both a Neoplatonic and an Aristotelian voice. Farabi also participated in writing books on early Muslim sociology and a notable book on music, titled Kitab al-Musiqa, the Book of Music. This book is, in reality, a study of the theory of Persian music of his day. Although in the West it has been introduced as a book on Arab music, he invented several musical instruments, besides contributing to the knowledge of musical notes. It has been reported that he could play his instrument so well as to make people laugh or weep at will. Farabi's treatise Meanings of the Intellect dealt with music therapy, where he discussed the therapeutic effects of music on the soul. Later life: Farabi traveled to many distant lands throughout his life and gained many experiences. As a result, he made many contributions for which he is still remembered and acknowledged. Despite facing many hardships, he worked with full dedication and made his name among the popular scientists of history. He died a bachelor in Damascus in 339 AH, 950 AD at the age of 80 years. Al-Battani 8589–9 Al-Battani is sometimes known by a Latinized version of his name, being Albatenius, Al-Bategni, or Albatenius. His full name was Abu Abdallah Muhammad ibn Jabir ibn Sinan al-Raqi al-Harani al-Sabi al-Battani. Al-Battani's father was Jabir ibn Sinan al-Harani, who had a high reputation as an instrument maker in Haran. The name makes the identification certain that Al-Battani himself was skilled in making astronomical instruments, and there is a good indication that he learnt these skills from his father. Early life and career: Abdallah Muhammad ibn Jabir ibn Sinan al-Battani al-Harani was born around 858 CE in Haran. Battani was first educated by his father Jabir ibn Sinan al-Battani, who also was a well-known scientist. He then moved to Rak, situated on the bank of the Euphrates, where he received an advanced education and later on flourished as a scholar. At the beginning of the 9th century, he migrated to Samarra, where he worked till the end of his life. His family had been members of the Sabian sect, a religious sect of star worshippers from Haran. Being worshippers of the stars meant that the Sabians had a strong motivation for the study of astronomy. Al-Battani, unlike Thabit, another mathematician from his hometown, was not a believer in the Sabian religion. His name Abu Abdallah Muhammad indicates that he was certainly a Muslim. Al-Battani made remarkably accurate astronomical observations at Antioch and Ar-Raqqa in Syria. The town of Ar-Raqqa, where most of al-Battani's observations were made, became prosperous when Caliph Harun al-Rashid built several palaces there. The Fihrist, who wrote a 10th century survey of Muslim culture, describes al-Battani as one of the most famous observers and a leader in geometry, theoretical and practical astronomy, and astrology. He composed work on astronomy, with tables containing his own observations of the sun and moon and a more accurate description of their motions than that given in Ptolemy's Almagest. The main achievements of al-Battani's are: he catalogued 489 stars. He refined the existing values for the length of the year, which he gave as 365 days 5 hours 46 minutes 24 seconds, and of the seasons. He calculated 54.5 per year for the precession of the equinoxes and obtained the value of 2335 for the inclination of the ecliptic, rather than using geometrical methods, as other scientists had done. Al-Battani used trigonometric methods, which were an important advancement. Al-Battani showed that the farthest distance of the sun from the earth varies and, as a result, annular eclipses of the sun are possible as well as total eclipses. Al-Battani is important in the development of science for a number of reasons, but one of these must be the large influence his work had on scientists such as Tycho Brahe, Kepler, Galileo and Copernicus. Death. Historians all agree that al-Battani passed away in 317 H. 929 AD, near the city of Mosul in Iraq. He was regarded as one of the most famous Arab astronomers. He dedicated all his life until his death to the observation of planets and stars. Ibn Sina 980, 1037, also popularly known as Avicenna. Ibn Sina was indeed a true polymath, with his contributions ranging from medicine, psychology and pharmacology to geology, physics, astronomy, chemistry and philosophy. He was also a poet, an Islamic scholar and theologian. His most important contribution to medical science was his famous book Al-Qanan fi al-Tib, the Canon of Medicine. This book is an immense 5-volume encyclopedia of medicine containing over 1 million words. It comprises of medical knowledge available from ancient and Muslim sources. His other major work is the Book of Healing, a scientific and philosophical encyclopedia. Early life. This great scientist was born in around 980 AD in the village of Afshana, near Bukhara, now in Uzbekistan, which is also his mother's hometown. His father, Abdullah, an advocate of the Ismaili sect, was from Bakh, which is now a part of Afghanistan. Ibn Sina received his early education in his hometown, and by the age of 10, he became a Quran Hafiz. He had memorized the Quran. He had exceptional intellectual skills which enabled him to overtake his teachers at the age of 14. During the next few years he devoted himself to Muslim jurisprudence, philosophy and natural science, and studied logic, Euclid, and Ptolemy's Almagest. Ibn Sina was an extremely religious man. When he was still young, Ibn Sina was highly baffled by the work of Aristotle on metaphysics, so much so that he would pray to God to guide him. Finally, after reading a manual by a famous philosopher Al-Farabi, he found the solutions to his difficulties, contributions and achievements. At the age of 16 he dedicated all his efforts to learn medicine, and by the time he was 18 gained the status of a reputed physician. During this time he cured Natu, ruler of the Samanids, of an illness in which all the renowned physicians had given up hope. On this great effort, the emir wished to reward him, and the young physician requested consent to use his exclusively stocked royal library. On his father's death, when Ibn Sina was 22 years old, he moved to Jurjan near the Caspian Sea, where he lectured on logic and astronomy. Here he also met his famous contemporary Abu Rayyan al-Biruni. Later he traveled to Ray and then to Hamadan, both in present-day Iran, where he wrote and taught his works. Here he also cured Shams al-Dawla, the emir of Hamadan, from a severe illness.